Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on November 12, 2025, about 3 days ago. The striking result is that this paper reports a system that completes 575 steps in the Towers of Hanoi using large language models with 0 errors, showing that extreme task decomposition and voting can make ultra-long processes reliable. The paper is titled, Solving a Million-Step LLM Task with 0 Errors. And as we will see later, the implications for scaling reliable multi-agent workflows are quite significant. Alright, Figure 1 contrasts 2 ways to scale, making costlier base models or using an orthogonal, meaning independent, approach based on decomposition and voting. The horizontal axis counts consecutive error-free steps, which means how many actions a system executes in a row without a mistake. The vertical axis uses cost per million tokens as a rough proxy for base model intelligence. The yellow point at the far right shows about 1 million steps, indicating the decomposed agentic system sustains reliability far beyond individual base models. Well, Figure 2 shows the core loop that makes the million-step run possible. The left panel implements Maximal Agentic Decomposition, so a microagent proposes exactly one action before passing state forward. The center panel runs first to ahead by K voting, which means sampling votes until one candidate leads by K and then locking it in. The right panel performs red flagging, discarding responses whose structure signals risk, improving both accuracy and independence across samples. So, Figure 3 shows that a modest vote threshold can turn noisy single steps into a near certain end-to-end success. The vote threshold K means the process stops sampling once one action leads by K votes. The left panel indicates that at 1 million steps, increasing K steadily pushes the solve probability toward 1, even when per step accuracy is only 90%. The right panel shows that with higher per step accuracy, a small K still supports reliability as the total steps grow. Together, these curves justify using only a handful of voters per subtask. Okay, Figure 6 presents empirical single-step error rates and projected costs for different base models. The left panel plots error rate against discount, which stays essentially flat, so long processes remain viable. The right table combines token price, per step error, and a vote threshold called K-min, meaning the smallest lead needed to stop voting. It highlights GPT 4.1 mini with low temperature as the most cost-effective choice with K around 3. So Table 1 summarizes the open-source base models and their usage terms that powered the microagents. This table lists model names, parameter counts, service endpoints, and prices per million tokens, which means the charge for processing 1 million text tokens. The entries span premium to lightweight models, and all were accessed through the Together AI API. Temperature was set to 0.1 for these runs, keeping output steady while voting handled reliability. Wrapping up, 2 takeaways stand out. Extreme task decomposition with simple voting and red flagging turns noisy single steps into an error-free million-step process, and reliability scales with only a small vote threshold that grows roughly with the log of task length. The broader implication is clear. Many cheap microagents can outscale bigger monolithic models for reliable, organization-level workflows. That is it for this episode of the AI Research Roundup. I'm Alex. Thanks for listening.